Hey, hello guys, this is Shubhabrata and welcome back to my channel circuiTician. As you know, I have been making videos in my channel from 2020 and I am working in the field of electronics, IoT, robotics and DIY stuffs from the last 7 to 8 years. As day by day work pressure is increasing, so I need more tools to do my work perfectly. So in this video, I will show you 5 of the tools which make my work easy and which helps me to do my work efficiently. So don't skip the video, watch till the end. Let's get started. When I have started my journey in electronics, I use THT components or through-hole type components to make my circuits. As day by day I have to make my circuit and PCB smaller, so I have to move in the section of SMD components. SMD stands for Surface Mounted Device. So in case of 1206 size resistor capacitor or bigger size component SMD components, you can solder with your bare eyes. But when it comes to solder any type of smaller connectors or any type of chips like LQFP package, QFN package, so you need a microscope. So I have bought a microscope for my soldering job and I will show you the features of that microscope and how to use that, and I will also show you some soldering jobs in the microscope screen. So let's do that. So here is the microscope. The price of this microscope is near about 3000 rupees. And I bought this in this new year 2023. And here is a PCB. This is basically a breakout board for LQFP package chips, and this is a 48-pin LQFP chip, and you will show some videos about this microcontroller in the upcoming video. And here you can see in the microscope screen that how larger the chip is. And this is the 8-pin TSSOP package. This is also a microcontroller. And now here you can see the microscope view. And in the center of this microscope there is a knob to adjust the focus, because you have to up and down the microscope to zoom in and out, so you have to adjust the focus. And this is the flight controller board, and the heart of this flight controller board is STM32. So here you can see the STM32 in the microscope screen. So you can easily see the smaller components in the microscope. When it comes to analyze any type of signal, an oscilloscope is a very useful tool. But as I can't afford an oscilloscope, I have a tool which can analyze only the digital signals in the level of 5 volt and 3.3 volt. The device is called a logic analyzer. A logic analyzer is a device by which you can analyze your PWM signals or any type of communication protocols like I2C, SPI, UART, Modbus, CAN bus, this type of, and many more. So let's take a look how the logic analyzer works and how to use it with your circuit. This is the logic analyzer. My logic analyzer can analyze up to a frequency of 24 MHz. And this logic analyzer is of 8 channels. And here are the pins where you can connect the jumper wires to analyze your signal. And there is a USB port. Basically this USB port is also present in Arduino Nano. So you can connect a USB cable between this logic analyzer device and your PC. And this is the logic software where you can analyze the signals. So in the right side there are some settings from where you can set up your logic channels for any type of debugging like UART, I2C, SPI, as I said before. And for now we will analyze the signal of channel 1. Basically here are from channel 0 to channel 7. So you can see the signal in channel 0. Basically we uploaded a blink code in the Arduino and we are measuring that frequency. So I have uploaded the blink code with 10 millisecond delay. So here you can see the on and off time is 10 millisecond. So by this method you can measure your PWM frequency and the duty cycles. And you can also use these markers to precisely measure the on and off times. And here is the off time we measured, that is 10 millisecond. In some of my videos, you must have seen that I have used my custom PCBs, means the DIY PCB which I have made in my workshop. So, if I tell you about the workflow of the PCB making process, so first we have to design a schematic, and for that I use EasyEDA software. Then we have to convert the schematic into the PCB, and then we have to print out that PCB layout in a photo paper from a laser printer. Okay, then we have to transfer that PCB layout from the paper to a copper clad board by using a iron, and this method is called toner transfer method. After doing this toner transfer, we have to etch the PCB. For etching PCBs, we have used ferric chloride solution, or we can use hydrogen peroxide plus HCl solution. In both the cases, we have to shake the PCB in the chemical container to get a better etching result. But shaking the container or stirring the chemical from 10 to 15 minutes is not feasible, and this task is very tedious for me. So to do this job, I made a PCB shaker. Let's have a look on that. This is the PCB shaker machine which I made before few months. And there is a crankshaft mechanism made by the motor, disc and this wooden stick, by which we are pushing and pulling this seesaw type mechanism. By pushing and pulling, we are creating a wave in the liquid present in the container, so we can etch the PCB very easily and efficiently. While shooting YouTube videos, we need some kind of special bright light sources to make our video better. As I am a technical content creator, I have to shoot the parts and the components which I used in my project. So for that, we need desktop light setup. And sometimes we also need colorful lights instead of only a white light. So for that, I have made a RGB desktop light setup. And in this setup, I have used a common anode RGB LED strip instead of pixel LED strip to decrease the overall cost. And to control these RGB LEDs, I use a ESP12F microcontroller chip along with the rotary encoder and TM1637 display. I have also used a 3S battery pack to make the system portable. And you can control the brightness or intensity of the red, green and blue LED individually to get a perfect color of the light. Here is my RGB LED light setup, and I made these LED light panels using common anode RGB LED strips, and the color you are visualizing now, this is warm color. Okay, and the stand of these LED lights is made by using PVC pipes, and the head is movable, and in the center you can see the rotating table, and there is different colors of the lights to shoot my video. And now you can see the blue color, and this is the controller of the RGB LED. In this controller I used a 3S battery pack for making this system portable, and there is the on-off switch of this controller, and this is the rotary encoder by using which you can control the brightness of each of the LED red, green and blue, and by pressing this knob you can switch between colors like red, green, blue basically, and you can change the value from 0 to 255, and you can see in the display. And this is a USB connector where I have connected all the RGB LED panels, and this is the balance connector of the battery for charging these batteries. If you are following me on Instagram, then you most probably know that recently I have bought a 3D printer. 3D printer is very useful when it comes to rapid prototyping. And in case of robotics, it is a very much needed machine. In the future, I will try to make some robotic system using this 3D printer and upload those videos in my channel, so stay tuned for that. This is the Enter 3 S1 Pro 3D printer which I have bought. The printer has a direct drive extruder and the nozzle can go up to a temperature of 300 degrees centigrade and the bed can go up to a temperature of 110 degrees centigrade. The control panel is a touchscreen control panel and I have a CR touch sensor auto bed level system. And this is the Cura software where we slice the 3D printing model, the STL file basically. And here you can see my 3D printer printing a 3D part. I hope you guys like this video. If so, then make sure you hit the like button and also comment down below that which tool you have liked most, and if you need any detailed explanation of any of these tools, then also comment down that below. And if you are new to this channel or seeing me for the first time, then make sure you hit the subscribe button and press the bell icon for notification about my video. And if you want to support our effort, then you can buy me a coffee. Link is given in the description, as well as you will get the link of the tools in the description. And the most important thing, be creative.